Yeah. Okay, so as you guys got the information to finish up your test a little bit later, let's start taking a look at our new stuff. We have talked about a lot of different things in circles and in triangles and stuff, so I just want to review some vocabulary here. So, of course, what kind of triangle is this? It's a right triangle, okay. In a right triangle, of course, any triangle has three sides. In a right triangle, one of those sides has a special name. Anybody remember what that is? The hypotenuse. And the hypotenuse is the side that is not part of the right angle. It's actually what we call opposite or across from the right angle. The other two sides are called what? They're called legs. Now you mentioned the word adjacent. Somebody else mentioned the word opposite. Those words, adjacent and opposite, are used to describe the legs at times. Because there's two legs, we have to distinguish them from each other. The problem is we cannot name them opposite or adjacent until we know what angle we are looking at. When we're looking at trig, we're either going to be looking at this angle here, call that A, or this angle here, we'll call it B. Until we know which leg we're looking at, we don't know which one's or which angle we're looking at. We don't know which leg is opposite or adjacent. What does adjacent mean? Next to. Or touching. So if we're looking at A here, this leg touches it. This is the adjacent leg. This would be the opposite leg. Opposite, of course, means across from. Touches the angle. If we're looking at angle B, this is the leg that touches that angle, so that's adjacent. This is the leg that's across from it, so that's opposite. But the opposite and adjacent depend on what angle we're looking at. Now, as we start talking about trigonometry, I meant bring up right triangles, and a lot of you think that trigonometry is about right triangles. It is not. Trigonometry is actually about circles. Now, we've done a lot of stuff with circles, and we know that, of course, this is if that's the center of the circle, that would be called a radius. And, of course, if I extend it all the way across, it's called a diameter. Now, a horizontal diameter is what's often called a reference diameter. It can be either horizontal or vertical on one of the axes, the horizontal or vertical axis. But it's called a reference diameter. Most often we use the horizontal one. On special occasions we use the vertical one. Now, of course, we have structures like this. What's that called? A secant. The chord is what's inside the triangle. That part there is a chord. But as the line extends through the circle, inside the circle, what extends through the circle, it's called a secant. What's it called if it does this? That's a tangent. It touches it in just a single point. Now, a feature that you might not be familiar with, if I pick a point on my circle, the distance from that point to the reference diameter. Now, distance is always measured at a right angle, at a perpendicular. That distance is called the sine of that point. So if we pick a point on the circle, its sine is the distance to the reference diameter. At this point, you have now seen the circle definition of the structure for the three main trig functions: sine, tangent, and secant. Now, some of you might be saying, "Other thing, what about that other one we hear about?" Well, that's actually not a main trig function. And I'll show you here in a minute where they all come from. Any questions so far? Okay, so as I said, trigonometry comes from a circle. Pretend that's round. And what we use is we use a circle. It's called a unit circle. And it's called a unit circle because it has a radius of 1 unit. I'm going to put a vertical diameter through here as well, but that darker horizontal diameter, of course, you might recall, is the reference diameter. So now if I draw in a radius here, this point, by the way, is what we call the initial side. It's at 0 degrees. We talked about angles being measured and difference in directions. We talked about navigation and direction, and that due east is 0 degrees, the 0 degree location. It's also called the initial side of our angles. That's where all of our angles start on our unit circle. So I draw in this radius here. Whatever this angle is here, let's say I call it angle A. It might be 28 degrees, 31, whatever. But we're going to call it angle A. That radius defines a point on the circle. First of all, how long is that brown line segment there? 1. Radius equals 1, right? So that brown line segment is 1. And it finds, because of that angle, it defines a point on our circle. What is this called? That's a sine. So the distance from that point that angle A defines on the circle down to our reference diameter, of course measured at a right angle, is the sine of angle A. On this unit circle, we need to define a tangent. Well, a tangent is going to be tangent to the circle at the reference diameter. So it could be tangent here or over here. Well, in this case, it's more useful to have a tangent here. Well, how far is it going to go? Well, it's going to go until it intersects that line defined by our angle A. That green length there is the tangent of angle A. Now, what about this length here where we extended that out to intersect the tangent? A line that cuts through a circle is called a secant. That length is the secant of angle A. So now if we look at this, we can see, since the radius of this circle is 1, what can we say about the size of the sine of that angle? Of any angle? Can it ever be bigger than 1? No, because the biggest that sine could be is if the point were here and it were going down to the reference diameter there. The biggest it could be is 1, exactly 1. So the sine of an angle can never be larger than 1. It actually has to be between -1 and +1. It can equal 1 at 90 degrees, but it has to be between -1 and +1. How about the secant? What can we say about the secant? It's always bigger than 1 because it always cuts outside the circle. So it has to be always at least 1 or larger. The tangent. Well, the tangent, if I'm looking at this circle here, if I have an angle way down here, that tangent can be really small, can't it? Yeah. Or if I have an angle way up here, that tangent can be really big, can't it? The tangent can be any value, from -infinity through +infinity. The tangent can be anything. Those right there, sine, tangent, and secant, are our main trig functions. Now, I heard somebody mention the word cosine, and probably a lot of you thinking about cosine, thinking, hey, we were taught it was sine, cosine, and tangent. What's going on here? What is a cosine? Well, cosine is a member of what we call the cofunctions. A cofunction is the function on the complement. So cosine is really two words put together. Co, which means complement, and our sine. So what cosine of an angle means to find the sine of the complement. Okay, so what on earth does that mean? Well, if I ask you to find the cosine of 60 degrees, what that's really asking me to find is the sine of, what's the complement of 60? 30, the 30 degrees. Those will be equal. They are the same thing. The literal definition of cosine of 60 is the sine of 30, the sine of its complement. Yes?
Is the sine and cosine, if you add them together, they always equal 1?
Not if you add them together, but there's a relationship between them that does equal 1, but not just adding them together.
Right.
So where on this picture is there an angle that's the complement of angle A? Right there, we'll call that angle B. It is the complement of angle A, isn't it? So what the cofunction does is it changes our reference axis. Our reference axis is now this one here. So the cofunction now, this would be the sine of angle B because it's the distance from that point back to its reference diameter, right? That is the sine of B, or the cosine of angle A, because B is A's complement. Does that make any sense? So what that means, now if I look at this unit circle, this distance here is going to be the exact same as this distance here. So often we look at that as being the cosine of angle A, because then we can look at it as being that the cosine is the x coordinate and the sine is the y coordinate of this point up here. The cotangent, cosecant, those all exist as well. I mean, we do our cotangent here, cosecant here. They all exist as well, but I'm not going to draw them into the picture. So what this gives us now is two triangles, two main triangles. This one here, and then this one out here, the bigger one. So we're going to start by looking at the smaller one in the middle and see what we get out of that. So that smaller triangle here, this is angle A. We defined the length of this side out here to be the sine of A right here, right? I'm going to abbreviate just SIN is how we abbreviate sine. And this side down here was cosine of A, right? I'm looking at this triangle right here. So that length on bottom was the cosine of angle A. Do I know the length of the hypotenuse? It's 1, right? It's the radius of the circle is 1. Now, you asked that question earlier, Mike, by the way. This is a right triangle. So do you see the relationship between cosine and sine? Yeah. Cosine of A squared plus cosine of B squared has to add up to 1 squared, or just 1. Next to this, I want to put a generic triangle, a right triangle, of course. And this is angle A. Now, if I know that these two angles, angles A are the same, and the right angles, of course, are the same, what do I know about this third angle up here? Yeah, it's going to be the same as this one. So these two triangles are similar. One's an enlargement or reduction of the other. Now, on this triangle, of course, this side was called the hypotenuse, right? if these other two sides are legs, but if we're looking at angle A here, which leg is this? This is the adjacent leg. It's touching angle A. It's next to angle A. This is which leg? The opposite leg. All that work we did with similar triangles and proportions and cross multiplying and divided, this is how we define our trig functions. So I'm looking at, well, let's look at sine first. So I'm going to look at the sine of angle A here, that side. And I'm going to compare it to its hypotenuse. The sine of angle A compared to its hypotenuse. In the other triangle, what side corresponds to the sine? That'd be the opposite side, wouldn't it? They're both that vertical piece. And then I put the 1 in here. What side on the other triangle corresponds to the 1? Well, the hypotenuse. Sine of A over 1 is equal to the length of the opposite side over the hypotenuse. In other words, the sine of angle A is equal to the length of the opposite side divided by the length of the hypotenuse. Many of you probably already knew that definition of sine. Let's look at the cosine. So the cosine of angle A, and we're going to compare it to its hypotenuse again. The only reason we're comparing it to its hypotenuse is because hypotenuse is 1, so it's easy to, the 1 really doesn't do anything for us. Right? What side on this other triangle corresponds to the cosine? The adjacent, right? And still corresponding to the 1 is the hypotenuse. So the cosine of angle A divided by 1, which is just the cosine of angle A, is equal to the length of the adjacent side divided by the length of the hypotenuse. So this triangle right here that comes from that circle that defines the sine and cosine, because it is similar or proportional to any right triangle that has an angle of A in it, we can find the sine or the cosine of the angle by just dividing the lengths of the sides. Now, and I know it's kind of a nitpicky distinction. You know, you've seen the trig functions defined this way. The sine of an angle is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. But they're not defined that way because of anything to do with the right triangle. They're defined that way because they're similar to a triangle that's formed within a circle. Now, what about tangent? Where does tangent come in? Tangent and secant. Well, we have this bigger triangle here yet. This one out here, right? Let's draw that one out. Now, this is still angle A. What's this length down here? That was the radius, right? All the way from here out to here, which is how long? 1. Very good. This height here is that's the tangent of A. And remember, this was it cut through the circle and went out. That was the secant of angle A. And we still have our other triangle here. This is angle A. This is a right angle. This is our hypotenuse. This is our opposite. This is our adjacent. So now to define tangent, what other side of this triangle do I want to use? The 1, right? Just like I did last time. So I'm going to put the tangent of A over 1. What side of the other triangle corresponds to the tangent? Opposite side. And what side corresponds to the 1? The adjacent side. So the tangent of an angle is equal to the length of the opposite side divided by the length of the adjacent side. So it's secant. We'll compare that to 1. If I'm looking at the secant, what side of the other triangle corresponds to the secant? The hypotenuse. And of course, we still have the 1. What side still corresponds to the 1? The adjacent. The secant of an angle is equal to the length of the hypotenuse divided by the length of the adjacent side. So let's look at what we've defined so far. Sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. Tangent of an angle is the length of the opposite side over the length of the adjacent side. Secant of an angle is equal to the length of the hypotenuse over the length of the adjacent side. Now, I wrote that down there. Why would I write that down like that? Because there's a link between the secant and the cosine. Anybody tell me what it is? They're reciprocals. Hey, you flip it over. Cosine's adjacent over hypotenuse. Secant's hypotenuse over adjacent. I could draw in those other triangles up top here, these ones up here, and do the same thing, but I'm just going to give you these other functions. Cosecant, abbreviated CSC. That stands for cosecant of an angle is equal to the hypotenuse divided by the opposite side. Why would I write that next to the sine? Because it's the reciprocal of the sine. Sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. And of course the next one is cotangent. That's going to be the adjacent side over the opposite side. Again, you see that next to tangent. Tangent's opposite over adjacent. Cotangent's adjacent over opposite. They're reciprocals again. So, first thing I'm going to say right now, pick a page in your notebook, back page, back cover, whatever, that you can find very, very quickly, and make sure you have this written down. Because most of what we do over the next 4 weeks or so is coming right off of this list. Need a little time to write it down? I'll pause. Here we go. So what does all this mean? You need more time to get it down? No. Sure? All right. So let's have a triangle here. I'm going to call it A, B, C. Now, when we label a triangle like that, remember the side that's opposite A is called little a. The side that's opposite B is called little b, and the side that's opposite C is called little c. And I'm going to label side B here is going to be 5 inches. Side A is going to be 12 inches, and C is going to be 13 inches. If I ask you to find the sine of angle B. Now, if I'm looking at angle B, remember sine is what? Opposite of hypotenuse. So I'm looking at angle B. What leg is the opposite leg?
5.
The 5. The hypotenuse is 13. So 5 over 13. You could divide that out if you wanted to, but you don't have to. Did 0.3846. Personally, on a quiz, I would accept it either way. I usually would just put the fraction. Why bother dividing it out? You know, it doesn't need to be divided out. If I ask you for the cosine of angle B, cosine is what two sides? Adjacent over hypotenuse. Well, the hypotenuse is still 13. If I'm looking at angle B, which leg is the adjacent leg? The 12. So that's 12 over 13. Again, you can divide it out if you want to. I'm not going to bother to do it here. If I look at the tangent of angle B, tangent is Opposite over adjacent, right? Opposite would be 5. Adjacent would be 12. Again, you could divide it out and make a decimal if you wanted to. Secant of angle B. Well, secant is hypotenuse over adjacent. What's the hypotenuse? 13. And for angle B, the adjacent is still the 12. So 12 over 13, or 1.083 if you divide it out. Cosecant of angle B is hypotenuse over opposite. So hypotenuse is still 13. Which side is opposite B? The 5, right? Notice both secant and cosecant are bigger than 1. How about cotangent of B? Cotangent is adjacent over opposite. So it would be 12 over 5. Those are all my trig functions from this right triangle. What if I ask you to find the sine of angle A? Sine is opposite over hypotenuse. If I'm looking at angle A, which side is the opposite side? The 12 is the opposite leg. 13 is the hypotenuse. Now you're going to notice something here. The sine of angle A equals the cosine of angle B. Why would those two be equal? Well, what do you know about angle A and angle B? If you add them together, what do you get? Yeah, the whole triangle has to add up to 180. If this is a right angle, that's 90. Well, 180 minus 90 leaves 90. These two angles have to add up to 90 degrees. So they are complements. So the sine of one has to equal the cosine of the other. So if I break the cosine of angle A, from angle A, the adjacent side is B, the 5-inch, over the hypotenuse of 13. Guess what? That's going to be equal to the sine of A, of B. Do you guys see how I'm getting these functions? Now, without even looking at the triangle, you should be able to tell me the tangent of angle A is 12 over 5. How do I know that? The tangent of A will equal the cotangent of B. Because they're cofunctions. The tangent of one equals the cotangent of the other. Cotangent of A would be 5 over 12. Same as the tangent of B. Secant of A, same as the cosecant of B, 13 over 5. Now you could use the sides of the triangles to find these too, but I'm just trying to prove a point. That once you know the functions for one, you know the functions for the other because they're just the cofunctions. What do you think? Kind of cool? Kind of boring? Just want to cry and go home?
Yeah, that one.
That one's a good option. Never seen it presented this way?
I've never seen Trig.
Oh, never seen trig? Okay. So now let's step back. What are we actually going to calculate today? Other than doing these ratios and stuff in the triangle, which are all cool, but that's the basic. What are we going to actually do? Well, we're going to have to use the calculator to do most of this. Back in the day, way before my time even, I've had the calculator for trig ever since I started. But before my time, before calculators were common, they actually had tables with all the trig functions listed out. So this whole cofunction here was huge. Rather than having to have a table for sine and for cosine, they just had a table for sine. And they listed it out to they actually listed out to usually like every 10 minutes, or it's like 1/6 of a degree. So if you wanted to find the cosine of 30 degrees, the table only had sine on it. It had sine and tangent on it usually. So if you wanted to find the cosine of 30 degrees, you had to look up the sine of 60. You had to know you looked up the complement. Does that make sense? Otherwise, their tables would be just huge if you had to have all 6 trig functions on there. It's always based off of a circle, but it gets applied to right triangles. It can be applied to other triangles that aren't right, too, and we're going to look at that in a few weeks. Those are called Drew triangles. because they're just not right. So, what if we're given the angle and we want to find the sine of 60 degrees? 60 degrees is what? Punch in your calculator. What'd you get? Sine 60.
-0.3.
If you got 0.866, your calculator is set correctly. If you got negative whatever, chances are your calculator is set to radians. So make sure you have it set to degrees. Do you know how to set your calculator to radians?
It looked like a button for it. So.
On the phone, I don't know how to do it.
I
On yours, you got a DRG key.
definitely think so.
Did you find it? Anybody else need to get their switch and don't know how? So try it again. Sine of 60 to make sure you get 0.866. How about cosine of 60 degrees? You get 0.5. Did you get 0.5? Okay, now I'm going to erase you for this one. Tangent of 60?
Alright. So
1.7.
you can play atomic calculator. Kind of what we wanted to do. Like throw this at you.
How the calculator does it? The calculator actually uses a, well, I used to use a Taylor series, where sine can be calculated without any trig functions. It's just 1 plus the angle over the angle plus 1 plus the angle over 2 times the angle. It's an infinite series. But because the calculator can...
Not as exciting as I thought it would be.
No. It's not like they programmed a table into the calculator and the calculator memorizes the table and just brings it up. No, it actually is a calculation that goes through. How about secant of 60 degrees?
Okay.
Your calculator don't have a secant button, does it? How to do secant? Well, we know that the secant of an angle is equal to the reciprocal of the cosine of that angle, correct? Now, you could just do 1 divided by the cosine of 60. It will give you the right answer. But we're going to do a fancy way of doing it because eventually we're going to have to do inverse functions. So the way we're going to do this is you're going to do the cosine of 60. Now, your calculator automatically pulls up a parentheses when you hit cosine usually. No? If it doesn't, use them. If your calculator doesn't pull up a parentheses, put the parentheses in. Cosine of 60. Close the parentheses, and then most of you have a reciprocal key that looks like this, x negative 1. What that is telling the calculator is take 1 and divide it by this number that's right in front of me.
I have a 1 over x.
1 over x would do the same thing.
I got
Should get 2. Try that and see if you can make that give you 2. That's different. We'll get to that in a couple days. Should get 2. You got to hit the reciprocal key yet. So on your calculator, cosine 60.
In other words, on your phone, you can do it on your phone too.
Oh, so on your calculator, you got 60 cosine. And then you've got a 1 over x right there. Shift 1 over x. Anybody else having problems?
Yeah.
So on yours, you're going to just cosine. Cosine. Yours is a reverse notation. And then you're going to hit 1 over x. So you got to put in the integral. Anybody else? You got them?
Wait.
Now you got to hit the 1 over x key.
Where's your
How about the cosecant of 60 degrees? Get 1.15? For cosecant now, you're going to put in the sine of 60 and use that x negative 1 key. Or for some of you that have the reverse notation, you're going to hit in 60, then sine, and then 1 over x. Yes, sir. On the cell phones, I don't have any clue how most of these work.
I figured it out on mine, so.
You've got a 1 over x key. Sine.
Do you have like some kind of smart calculator app on there?
No, this is just the regular iPhone calculator.
Oh, no, your 1 over x is different. You've got to hit the 1 over x first, and then you've got to hit the sine
I
of
got it.
60.
Oh, you already got it.
So did you get 1.15? About?
Yep, man.
How about cotangent of 60 degrees? Anybody want to guess how we're going to do this one? You got it. Tangent of 60, then the reciprocal key. Get 0.577. In your textbook, on page 719, it is exercise 33-3, page 722, exercise 33-5A, and page 724, exercise 33-5B. Those go over the stuff we did today. Yes, we will take some more time tomorrow to go over it if we need to. How many of you are ready to turn in your test, and how many of you need to wait till tomorrow?